We are automating almost everything using AI agents, and in this video, I'm going to show you how you can build an AI vision agent using Gemini Vision API. We are not afraid of giving it access to our file, our browser, or any sort of API we are using in our system. So, in this video, I'm going to give it access to screen share stream. So, let me start with a quick demo. So, I created this meeting interface. So, let's start a session quickly. I can invite this AI agent. Hey, how are you doing today?
Hello, I'm here and ready to assist you. How can I help you today?
Okay, so what I'm gonna do now, I'm going to give it access to this screen. I've written this code and I'm pretty sure it's not correct. Okay, so I'm sharing my screen. Let me enable my mic. Hey, I have this Fibonacci function on my screen, and as I run this code, can you tell me what's going on?
The issue with your Fibonacci function is in the return statement. You're trying to return fib n plus 1, but JavaScript uses zero-based array indexing. So you should change it to return fib n to access the correct Fibonacci number. This should resolve the undefined output issue.
Okay, so I've changed it to Fibon and now I'm getting 5. So I hope that's the correct Fibonacci number.
Yes, that's correct. The fifth Fibonacci number is indeed 5. Your function is now returning the expected result.
Okay, so first let's quickly start with this project. To get started with this project, you need VideoSDK's authentication token so that you can make authorized requests to VideoSDK's endpoint. So in API keys, you can simply click this key icon to generate your authentication token. So once you generated that, inside your client app, you will find this template code. So simply change it to .env file and simply add that authentication token here. And on server side, we need OpenAI API key and Gemini API key. To create OpenAI API key, you can navigate to platform.openai.com/API keys. Here you can create your API key. You can give it some name. You can select project and simply create your API key. Next, for Vision, we need this API key that we can get at AI Studio. So we are implementing something similar to this AI Studio, but it is inside a meeting conference with a lot of participants. Okay, so once you have OpenAI API key and Gemini API keys, so simply create a .env file and add these API keys. So to run our Python server, first you have to create a virtual environment, which you can do by executing this command. Once you do that, you have to activate that script. So this activate script, you have to execute that script. As you can see, I'm inside virtual environment and all the packages used by this application are mentioned inside this input file, which is requirements.txt. So all you need to do is to install all these packages. For that, you can simply run this command pip install and then this input file. And to run client app, so inside this client folder, first you have to install all the dependencies that are required for our client application to work by simply doing this npm install, and then you have to execute that dev script. So if you check out package file, then you will find this dev script that you can execute. Okay, so let's run our server as well. So if you check out, our client is running on port 5173. Here we can create a session. We can provide some name and then we can invite an AI agent. Okay. Hey,
Hello. Sure. What would you?
actually, I just finished with project setup.
Great. If you need any help or guidance with your
So it's very simple to set up. Let me walk you through the high level architecture of our system. We have a client server setup where front end is built using VideoSDK's React SDK, creating a meeting interface where human participants interact. When someone wants to join an AI agent, they simply make a post request to this Python server by specifying meeting credentials like meeting ID and authentication token. So if you look at this code, in this main file, we are using fast API to build an API application. So here we created this route join player that is triggered by client. So here we are accessing, first we are creating a background task because we want to keep the server running in background. So here, as you can see, we are accessing meeting ID and authentication token through request body, and then we are initializing an instance of an AI agent. So we are going to discuss this AI agent class in next segment. Okay, so once this instant is created, then we are joining this AI agent by simply calling this join method. So we are going to talk about this join method as well. So that's what happening here. This session is first started by client, then client shares this meeting credential to Python server. So what's happening here is, so both client and server, they are disjoint from each other. They are accessing VideoSDK resource through VideoSDK packages. For example, on client side, we are utilizing NVIDIA SDK's React SDK to access all the meeting state, all the participant, and everything related to meeting. And similarly, we can access that same resources on server side. Obviously, we don't have an interface on server side. So having that meeting ID and authentication token help us create a pointer to an existing meeting. You'll understand it through this client app. Let me restart it. Oops. Okay, so here I'm starting a meeting. I'm providing my name. So when I click that start meeting button, a meeting ID is created for me. And when I click this join meeting, as you can see, I've joined this client app. So human participant is the one who is uh, initializing this current session, and then it is sharing these meeting related information to Python server. So here, when I click this invite agent, as you can see, I've invited this AI agent to an existing meeting. Now let's try to understand how our AI agent class work. So AI agent class is responsible for joining an AI agent to an existing meeting. It is responsible for accessing active participant media stream, such as audio, video, screen share stream, so that we can analyze it on server side, and we can make use of some existing AI services uh, to process those stream, right? So just like human participant, we are preparing basic meeting configuration for our AI agent, like what is their name, which ongoing meeting they wants to point to. Obviously, it is an AI agent. It doesn't have access to custom microphone audio track, so we have to create a custom microphone audio track for this AI agent. So if you check out this meeting configuration, so it's a class from Video SDK, and you will know all the options available to you. For example, you can you can add additional information through metadata. You can also create custom video track. You can create your custom participant ID, right? Whoever is joining, you can create your own ID for that agent. I mean that participant. Next, we are explicitly calling this init method to create an instance to an existing meeting. And next, we are attaching basic local and remote event. For example, if you check out this meeting handler, it is just extending meeting event handler from Video SDK. So we will be notified whenever someone's joined this existing meeting, whenever they left this existing meeting. And there are other methods that you can override. For example, if you check out this on meeting joined method, here we are connecting to OpenAI WebSocket server. And if you check out this remote event, which is on stream enabled, here we are accessing. Here we are continuously accessing active participants audio stream, and we are handing it over to OpenAI real-time API so that it can create that custom audio track for our AI agent. Whenever active participant enable their screen share stream, we can also process that on server side. Before we transition into code directly, first I want to explain how everything is working together. So, with this AI agent, I can have real time conversation, and it can analyze my screen content whenever I'm asking for it. For example, if I ask some normal question like, "Hey, it is the date today."
Today is Tuesday, March 25th, 2025. How can I assist you further?
So I'm having this on-to-on real-time conversation with this AI agent. It is not making use of Gemini Vision API. And let's say when I ask for it, in that case, it is going to make use of function calling, and then it is going to analyze what's going on my screen in real time. So let me ask for it. Hey, can you help me with this Fibonacci function? I'm supposed to get this fifth Fibonacci number, but all I'm getting is this error on my screen. Can you analyze for me?
Sure, I can take a look for you. Let me analyze the screen to understand the issue with your Fibonacci function. It appears your code is missing closing brace in your Fibonacci function. Add this closing brace. After making this change, click the Run button, and your code.
I clicked the run button and I'm getting this undefined value. Is it because of this return statement?
Yes, the undefined value is probably due to the return statement. You should return fib n instead of fib n plus 1. Here's the corrected line. Return fib n. Rerun your code after making this adjustment, and you should get the correct fifth Fibonacci number.
Okay, so it is working fine now. So the fifth Fibonacci number is 5. That is correct, right?
Yes, that's correct. The fifth Fibonacci number is indeed 5. I'm glad it's working for you now.
As you can
If you
see,
have any more questions, feel free to ask.
so this AI agent is having real-time conversation as well as it is smart enough to know when to make an API call. So now let's try to understand how OpenAI real-time API is working and when it is deciding when to make an API call. Now let's try to understand how OpenAI real-time API is working. So everything starts from that stream enable method. Whenever participant enable their stream, we can access their audio stream. We can access their screen stream so that we can analyze it through Gemini Vision API. So if you check out this method here, we created a task to manage this audio stream for active participant. So inside this method, we are sending this audio stream participant name, and then we are converting it into a PCM format, which we can hand it over to OpenAI real-time API. So we are calling this method send audio data from this intelligence instance. So if you check out this OpenAI intelligence class here, we are first converting this into base 64 encoded so that we can send it over the network, and then we are calling this method send request. Here we are sending this audio stream to OpenAI WebSocket connection, and here you will find when this connection is created in this receive message handler, we are going to get a response from OpenAI. So I created this method handle the response to handle the response from OpenAI. So we get response in form of deltas and transcript, right? So there are different event we can listen to. We can also listen to this function calling. This function call event, in demo, I was asking for analyzing my screen. So it is going to understand which function to trigger in my software. For example, this function is triggered whenever user is asking for it, and this function is defined inside this AI agent class. Here in this handle function call, what we are doing, we are accessing the current frame of our shared screen. We are making use of Gemini Vision API to analyze what's going on that screen. So I've already given you a demo how it is working. That's all you need to know. I think I explained you all the details that is involved in this project. We discussed client setup, server setup. So I request you to try out this example and let us know if there are any improvements that we can make. And don't forget to give it a star. That's all from my side. Thanks for watching this video.